Good morning, my dear students. In this video, we are going to see economic dispatch problem without losses. Is another name for optimum generation allocation with the line losses neglected. So, what is meant by economic dispatch problem? It is meant by economic dispatch problem means the economic dispatch problem means the given network for a given network of a power generators, the economic dispatch problem is concerned with finding how much power each generator, each unit should be generated for a given demand while minimizing the total cost of operation cost, which is generally expressed in terms of nonlinear form, is called as economic dispatch problem. So the economic dispatch problem means for a given network of a power generators, the economic dispatch problem is concerned with finding how much power each unit should be generated for a given load demand, while minimizing the total cost of power generation, which is generally expressed in terms of nonlinear form. Suppose n number of units are connected in the power generations, the total cost, the economic dispatch problem is defined as the minimum, the objective function, objective of total cost of function in power generation. The objective is a calculate the minimum overall cost of generation. Or economic dispatch problem is defined as is a f minimum f of t equal to f1 plus f2 and fi plus and soon fn equal to the overall. To write the overall economic dispatch problem is defined as minimum f of t equal to the summation of n equal to 1 to n f of n and subjected to constraints. So here the constraint total power generation equal to total load demand. This is the constraints by using in the derivation subjected to constraints, subjected to constraints, total power generation equal to total load demand. To write the equation form PD equal to the summation of n, PD equal to pg1 plus pg2 plus pgi plus and soon pgn. To write the simple form PD equal to the summation of n equal to 1 to n and pn, where capital F of T is the total fuel input of the system and Fn is the fuel input to the nth unit and PD is the total load demand and Pn is the generation of nth unit. So in the above equations, the constraint function PD equal to the summation of n equal to 1 to n Pn in the above equation is having constraint, so that it cannot be solved by using ordinary minimized techniques. So in the above equation involve the constraint function does not solve by the normal equations. By using the solution of above problem can be obtained. The above problem can be obtained by using the simplex method of generation, simplex method of optimization, loading of each generation, loading of each generated of a constraint inequality constraint equal to pg minimum less than or equal to pgi less than or equal to pg. So this technique which say that the constructed a auxiliary functions. So by making the Lagrangian multiplier by using the auxiliary functions, the auxiliary function is obtained by the auxiliary function is obtained. The auxiliary function means that it consists of main function and the main functions and constraint functions is called as auxiliary function as auxiliary function. So finally to write the auxiliary function f equal to f of t plus lambda into constraint function. So here the lambda in constraint function means f equal to f of t plus lambda into pd minus the summation of n equal to 1 to n and Pn, where lambda is the Lagrangian multiplier, where lambda is the Lagrangian multiplier. So by use the if the auxiliary function is minimized, then the main function is also minimized along with the constraints. So auxiliary function, once auxiliary function is minimized, the main function is minimized along with the constraints, and differentiating f with respect of generation Pn and equating the zero gives the condition of optimal operation and gives the condition of optimal operation of the power system. Differentiate with respect of Pn by the above equations. Delta df by dpn equal to the d by dft by dpn plus lambda into dpd by dpn minus summation of n equal to n to pn. Then finally we write the equation df by dpn equal to dft by dpn plus lambda into 0 minus 1 equal to 0. So finally it will equal to dft by dpn minus lambda equal to 0. Then you can find out the lambda equal to dft by dpn. We know that the overall cost of function f of t equal to f1 plus f2 plus and soon fn. To write the above equation form, the dft by dpn equal to fn by dpn equal to lambda. Here the lambda is a Lagrangian multiplier. And therefore the condition for optimum generation equal to delta f1 by delta p1 equal to delta f2 by delta p2 and soon delta fn by delta pn equal to lambda. Here the delta f1 by delta pn equal to incremental production cost of plant in n in rupees per megawatt hour. So the incremental production cost of given plant over limited range is represented by delta fn by delta pn equal to fnn pn plus fn. Here the fnn means slope of incremental production cost curve and fn means intercept of incremental production cost curve. This is the economic dispatch problem. So once again the repeat for economic dispatch problem. Here economic dispatch problem means the for a given network for power generators, the economic dispatch problem is concerned with how much power is generated by the each generator for a given load demand is equal to the economic load dispatch problem. So there are number of units and there are number of generators connected in a power system. The overall objective to calculate the overall cost of function, nothing but economic dispatch problem, is defined as minimum f of t equal to summation of n equal to 1 to n and fn and fn. Here considered for the inequality constraints and considered for the equality, what are the constraints are involved. So the constraints means the total power generation equal to total load demand. So power generation equal to PD equal to P1 plus P2 plus P and soon Pn. Here the PD, to write the overall summation of PD subjected to constraints, PD equal to the summation of n equal to 1 to n and Pn. Here Ft is the total fuel of input of the system and Fn is the fuel input to the nth unit, and PD means total load demand and Pn is the generation of nth unit. So here the above equation having involved the consisting of constraints function. The constraints function does not the constraint the above function having constraint so that it cannot be solved by using ordinary minimized techniques. The solution for the above problem by obtaining the simple method for optimization, nothing but auxiliary function. Auxiliary function means the consists of main function plus lambda into constraints function, and then finally write the equation auxiliary function f equal to, this is the main function f of t plus lambda into the this is constraint function fpd minus summation of n equal to 1 to n and pn, where the lambda is the Lagrangian multiplier. So the Lagrangian multiplier, so if the auxiliary function, if the auxiliary function is minimized, then the main function and the main function is also minimized along with the constraint functions. Differentiating with f with respect of pn, with respect of generation of Pn and equating the zero, it gives the zero with the condition for optimal operation. So df by dpn equal to dft by dpn plus lambda 0 minus 1 into equal to 0. Then finally dft by dpn minus lambda equal to 0. If the f of t means since f of t equal to f1 plus f2 and soon fn, to write the equation above equation as similarly dft by dpn equal to dfn by dpn equal to lambda, and therefore the condition of optimum generation is delta df1 by dpn equal to df2 by dpt and soon dfn by dpn equal to lambda. Here the dfn by dpn is the incremental production cost of plant. It is generally measured for rupees per megawatt hour. So incremental production cost of given plant over a limited range is represented by delta fn by delta pn equal to fnn into pn into plus fn. Here the f of fnn means slope of incremental production cost curve, and fn means intercept of incremental production cost of curve. Is I read the above equation is also dc by dpgi equal to 2 into ci pgi plus into bi is the similar equal to the fn equal to bi. It is the intercept of incremental production cost of curve. This is one. The next topic is a flow chart. How to flow chart? Draw the flow chart for economic scheduling without losses. So let the quadratic equation of power generation. So input in quadratic equations. Fi equal to ai plus bi into pgi plus ci into pgi square. Here the fi means fuel input of the system, and pgi means power generation, nothing but pn, and PA generation, nothing but here they are differentiated with respecting of power generation. dfi by dpg equal to 2 into pg square means 2 into ci into pgi and bi. So bi equal to lambda. So here the 2ci means fnn and bi means fn. To finally write the power generation equation, pgi equal to lambda minus bi by 2ci. Here the 2ci means incremental. 2ci means 2ci nothing but fnn, the slope of incremental production cost of curve, and bi means incremental intercept of incremental production cost curve. To draw the flow chart in this economic dispatch without load. So here the start by using the ellipse symbol. So start and read the values. What are the values are included in the equations, and fnn and fn and nothing but bi or ci and ai and pgi. So read the values ffn and fn and total load demand pd and epsilon and a epsilon. And next the step is the represented by triangle, represented by the mm, represent next equations here. So first one is the start, and what are the values are included in the above equations. Read in fnn comma fn and bd and epsilon. So assume the suitable values of lambda and delta lambda. Assume the suitable values of lambda and delta lambda. Delta lambda means change in the Lagrangian multiplier. Set n equal to 1. The next step is go to set equal to n equal to 1. In the above equation, substitute here set equal to n. So solve the above equation. Here the pn. So pn nothing but pgi. So lambda minus bi into ci. Put I equal to set equal to 1. N equal to n means 1 means n. So set equal to n equal to I. So here pn write the equation, solve the equation. Pn equal to lambda minus fn by fnn. So set n equal to 1. So p1 equal to lambda minus f1 by f11. So if you take if you generally, yes, you already specified the minimum value and maximum value. So here the pn check by using the diamond symbol. Check if pn is greater than pn maximum, the condition will be satisfied. Set pn equal to pn maximum. Here example, you got the values of 200 megawatts. Generally it is a n maximum value is 500 megawatts. So if generally have specified the 100 megawatts, so pn is greater than pn maximum. If the condition is satisfied, yes, you set equal to pn into pn maximum. And if the condition is not satisfied, and go to check if pn is less than pn minimum, the condition will be satisfied, yes, set pn equal to pn minimum. And if the condition is not satisfied, set equal to n equal to n plus 1. The similarly first n 1 plus 1 2, and you go to next step, check if all buses have been accounted. The chief check it all buses have been accounted. If the condition is not satisfied, go to the step here, the solve the equation, the generation equation, Pn equal to lambda minus Fn by Fnn. If the condition is satisfied, and calculate the delta P. Delta P means the total power generation minus total load demand, the change in power. So here the condition, check all the buses have been accounted, the condition will be satisfied, we then go to S. So calculate the change in power delta F. Delta F equal to the modulus of sigma summation of, or sigma summation of Pn minus Pd. If the go to is delta P less than epsilon, epsilon means it is pre-specified value, delta P less than epsilon. So if the condition is satisfied, then print generation and calculated the cost of generation and the end. If the if condition is not satisfied, and no, if is del summation of summation of Pn minus less greater than the Pd. If the condition is no, if the condition is no, lambda equal to lambda plus delta lambda, and go to the set value. Once again the set value will be changes, and then if condition is satisfied, lambda equal to lambda minus delta lambda. Once again you go to set equal to n plus 1. The procedure will be repeated. So n equal to 1 or n equal to the same will be the delta P epsilon value, some represent some assumed value sigma, sorry, summation. If the condition is satisfied, the print generation and calculate of the cost of generation, and the program will be ended. So once again, the flowchart for economic load dispatch. First, what are the values are included in the equations Fnn and Bfn and Pd and epsilon. Assume the suitable values of lambda and delta lambda. First, initially n equal to 1, set the value of n equal to 1, and substitute those values in Pn equation, lambda minus Fn by Fnn. So here the lambda minus F1 by F11. Check if it is the Pn is greater than P maximum value. If the condition is satisfied, set Pn equal to Pn maximum. If the condition is not specified, not satisfied, then go to check if it is a Pn is greater less than Pn minimum. If the condition is satisfied, then go to set as Pn equal to Pn maximum. If the condition is not satisfied, the set one value, set n equal to n plus 1 value, and then check if all buses have been accounted. So no, have been accounted, no, the condition is not satisfied, then go to solve, then once again. So Pn, if condition is satisfied, the calculate the change in power equal to change in power equal to change in generation, generated power minus load demand. If then next step is the change in calculated power, if delta P is less than the epsilon. If condition is satisfied, the print generation and calculate the cost of generation and end the program. If condition is not satisfied, is the summation of Pn is greater than the Pd. If condition is not satisfied, then go to lambda value, assume value lambda equal to lambda plus delta lambda. If condition is satisfied, the lambda equal to delta lambda minus delta, then go to the initially st set n equal to 1. This is the flow chart for economic load dispatch. Thank you.